Jump to number 16 on worksheet 8.7 WSPN. The A value is not 1. Once again, the A value is not 1. If it were 1, then you could jump straight to this, where you put W times W, because W times W gives you W squared, but the 3 messes it up. If the A value is not 1, then you can't do any of this. The shortcut is out the window, right? So what are we going to do? We're going to use that long process. Straight from your notes. Step 1 is to multiply A times C. And step 2, think of the multiples of that number that combine together to give you the middle value. Step 3, get that pair of numbers from step 2 and rewrite your B value as those two numbers, thus changing your trinomial to a polynomial. And step 4, factor by grouping. So let's go through these steps. Step 1, A times C. A times C is 24. And again, it's important that you look at the signs. It's a positive 3, that's a positive 8, so it gives you a positive 24. If you go and read step 2, is to make a list, right? Make a list of the multiples of that number from step 1. So the question is, how could we get 24? Well, it's going to be 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's about it. Those are all the possible ways of getting 24. So what we have to ask ourselves is, which pair of numbers combines together to give us the middle value, which happens to be positive 14? Well, if you add these, you get 25. If you add these, you get 14. So this must be the pair of numbers. There is no need to change signs because 2 plus 12 is 14. So we're ready to move on to step 3. Step 3 is a little bit more interesting. Step 3 is where you just rewrite this whole thing, but instead of 14W, you're going to write it as 12 or 2W plus 12. So again, you're going to rewrite the whole thing, but instead of 14W, you're going to replace it with these two numbers, and of course, you're going to add on the W's to the numbers. So there it is. You have 3W squared, 3W squared. You have plus 14W. If you think about 2W plus 12W, that really is the 14W that we originally had up there. And this is step 3, where you convert your trinomial 1, 2, 3 to your polynomial 1, 2, 3, 4. Not only that, I strategically left a gap right here because the whole purpose of changing it from 3 terms to 4 terms is to do factoring by grouping. So when I look at my first group, the first 2 terms, what could we factor out of the first group? What's in common? W, just W. So if I pull out a W from both of these, what's going to be left on the inside? Okay, and when we look at the other one, the other 2 terms, the other group, what could I pull out of both terms of that one? Pull out, you might be thinking 2, but that's not the greatest. Yes, 4 is the best. Pull out the multiple of 4, and notice that since I'm pulling out a 4 from both of them, I put a plus to represent a positive 4. Okay, you need to do that. And what would be left on the inside of the parentheses? 3W plus 2 also. Thank goodness, right? Let's not forget that this is an equation. It is equal to 0. It's right here. We'll deal with that equal to 0 later. Right now we just want to factor by grouping. So the next step on factoring by grouping is to look at your first group, look at your second group, and pull out what's in common, which in this case is a binomial. So we're going to pull out this 3W plus 2. Once again, pull out the 3W plus 2, put it out here in the front. So if I pull out the 3W plus... Whoa, sorry about that. Nothing's happening here. Let me see. Here we go. Let me try that again. If I pull out the 3W plus 2, what's going to be left? Just the W. So let me put the parentheses here, and I'm just going to bring down the W. And if I pull out the 3W plus 2 over here also, what's going to be left? Just the plus 4. So you might as well just write it together instead of exaggerating parentheses the way I normally do. And there's your factored form. Okay, so this, actually the original quadratic trinomial is factored into this. Now we still have the equal 0. Right, we still have this equal 0 over here. So we still have the equal 0 down here with that factored form binomial times binomial. So now what we're going to do is use the zero product property to split them and solve. The zero product... What? Sorry. My tongue just went crazy. The zero product property says that if you multiply something times something and it equals 0, the first something could be 0 or the second something could be 0. So there we have it. We set up the first binomial equal to 0, the second binomial equal to 0. So now we have two simple equations that we could solve. Let's do the blue equation first, the one on the left. So I'm going to subtract 2 on both sides. And then after that, I'm going to have a 3w equals negative 2. My final step will be to divide by 3, which means that your final answer is w equals negative 2/3. That's one answer. Let's do the other one. The other one's super easy. It's a one-step equation, bless you. So you're going to take away 4 from both sides, cancels. You will have your answer w equals negative 4, your other answer. We are done. Yes, it takes a while. It took us 5 minutes on this video to go through that whole process. But those are the two answers for number 16. Let's try another. Number 20 is interesting because the equation is not even set to 0 yet. All right? So whenever you have, they say solve, so the first thought that you should have is I need to get p by itself. But the problem is you have p squared and p, so that's like having two different types of p. P's. Okay, whatever. So you want to get p by itself. You can't get p by itself because there's two different types of p's. Okay. So I'm going to set it equal to 0. That's going to be my first step. Subtract 10, cancels. Subtract 10. Your new equation will be 8p squared minus 16p minus 10 equals 0. Now that you have the equals 0, now you want to try to factor so you could get a situation where you're multiplying, so you could actually split them and set them each equal to 0 using the zero product property. But what you're supposed to try to do before any other type of factoring method is the original factoring method that we learned, which was factoring out the GCF. Is there a GCF in all three terms in this case? 2. So we're going to pull out a 2. Bless me. So you're going to pull out the 2. What's going to be left? 4p squared. And the next term is going to be a negative 8p. And the last term is going to be a negative 5. Equals 0. Now because this is an equation, you could do anything you want to an equation, as long as what you do to one side, you do to the other side. So I could take the whole left side of the equation and say divided by 2. Why would I do that? So the 2's disappear. And as long as I do it to the other side, 0 divided by 2 is still going to be 0. So let me rewrite my new simple quadratic trinomial equation. There it is. Now the only thing I've done is made the numbers nicer, easier to work with, right? If we compare it to the original, if I just jumped right into it with the original, and I went, step 1's a times c. 8 times 10, that's 80. That's a bigger number. Now down here in the simplified one, 4 times 5 is 20. That's easier to work with. So you could have gone with the original, but this is a lot easier to work with. So please always try to factor out the GCF before beginning any other type of factoring method. Step 1, a times c. That's going to be what? Negative 20. Step 2, think of the multiples of negative 20 that combine together to give you negative 8. So you want to make a list. And those are your possible multiples of negative 20, of course changing the sign. So which pair of numbers combines together to give us the middle value negative 8? The 2 and 10, the negative 2 and 10. However, if I do combine negative 2 plus 10, that will give us a positive 8, and we know that we want a negative 8. So we have the right numbers, we just have the wrong signs. So let's change that to a positive and change this positive 10 to a negative. So this is the correct pair of numbers, positive 2 and negative 10. Those are the right pair of numbers that we want as we move on to step 3, which would be to rewrite this whole thing, but instead of the middle value negative 8, you rewrite it as 2x minus 10x. I'm sorry, p's in this case, 2p minus 10p. So there it is. I rewrote the original trinomial, but now the middle term became these two terms. And again, 2 plus negative 10 is negative 8. So I really didn't change anything. I just changed the way the middle term looks into two terms. All right. So why did I change to 4 terms? So I could apply factoring by grouping. And factoring by grouping, notice I already left space between the first two terms and the second two terms. If I were to pull out something from the first group, what would it be? What's the GCF? 2p. So I'm going to pull out 2 and a p. What would I have left if I pull out a 2p? 2p plus 1. Okay. And how about the second group? What could I pull out of the second group over here? A negative 5. You could pull out a 5, but pulling out a 5 would mess things up, because if you pull out a positive 5, you're going to have a negative 2p right here and a negative 1. And as you can see, over here you have positive 2p and positive 1. Right here you have negative 2p and negative 1. So that's not good. Let's pull out a negative 5 instead. Let me erase this. Let's pull out a negative 5 instead. That way we could get the same exact binomial. So I want to pull out a negative 5, and on the inside I will have 2p plus 1. Same exact binomial. Let's not forget that this is an equation equal to 0. But let's continue factoring by grouping. So I want to pull out the binomial that's in both the first term and the second term. I want to take the 2p plus 1 and the 2p plus 1 and put it out here as 2p plus 1. So when I pull out the 2p plus 1, the 2p is left over. And also, when I pull out the 2p plus 1, the minus 5 is left over. And let's not forget, this is an equation equal to 0. So the whole purpose of us factoring, going through all those steps, is to be able to split them and solve. So we're going to have two equations, 2p plus 1 equals 0 and 2p minus 5 equals 0. Solving the one on the left, you're going to have to subtract 1 on both sides. That would give you 2p equals negative 1. And then you would divide by 2 and divide by 2. And that's your final answer. P equals 1/2. P equals 1/2. Actually, negative half. Your other one, you're going to add 5 to both sides. You're going to end up with 2p equals 5. Final step would be to divide both sides by 2. And that gives you the answer p equals 2.5, or you could leave it 5/2. It's a lot of work. Let's check out one more. For the sake of time, I'm going to be doing this super quick because we don't have enough time. I'm going to add 15 to both sides, which you cannot do, so we're just going to rewrite it. So there it is, equal to 0. Now we could go through the process to all those steps to factor it, to be able to split it, to solve it. So step 1 is a times c, which is 60. Let me make some more space here. Step 2 is to make a list of the multiples of 60 that combine together to give us negative 16. Here's the list. Out of all these pair of numbers, the one that combines together to give you the middle value, negative 16, it's not exactly 6 and 10, but it's actually changing both signs. Because the 6 and 10 give you a positive 16, but now that we've changed both signs, it does give us a negative 16. So moving on to step 3, rewriting the equation, but making this middle value be these two numbers, negative 6 and negative 10, with a's on them, of course. Sorry about that. Anyways, I already separated the first group and the second group. Out of the first group, you could pull out a 2a, and on the inside, you'd have a 2a minus 3 left over. And out of the second group, you could pull out a negative 5. And if you pull out that negative 5, you're going to have the same exact binomial 2a minus 3. The next step would be to pull out what's in common in both groups, which would be the binomial 2a minus 3. So I'm going to put the binomial 2a minus 3 down here out in the front. So when you pull out the 2a minus 3, there will be a 2a left over and a minus 5. Again, 2a minus 5 will be left over. From there, now that we have it in factored form, we're going to split them and solve. And now we're just going to solve both equations. The red one, you'll have plus 3 on both sides, giving you the new equation 2a equals 3. Then we would divide both sides by 2. Do your final answer 3/2, or 1.5. Sorry. On the other equation, we're going to add 5 to both sides, giving us a new equation 2a equals 5. Final step would be to divide by 2 on both sides, giving you a equals 5/2, or 2.5.